All right, everyone, we're getting close to starting here. I'm just going to take one more minute to let any latecomers join us, and then we'll go ahead and get started. All right, everyone. Thank you so much for coming to today's Thought Leader webinar series, Optimizing Production Energy Metrics. I'm really excited. We have Alex and Justin joining us today. They've done a really great job at preparing some slides that I think that are going to be really relevant for us today. And if you could go to the next slide for me, Alex. I will be today's host coming from the Hobo side. My name is Xander. I'm the product marketing manager. And my job is basically to make sure that the right kind of data loggers get in front of the right kind of people. Next slide, Alex. A couple of logistics before we get started here. The webinar will run for approximately 45 minutes with 15 minutes of Q&A at the end. You'll notice that there's a little questions panel as part of the little pop-out. If you have any questions during the presentation, please go ahead and type them in at any point, and we'll address as many as we can at the end of the presentation itself. Also, this webinar is being recorded, so if you can't stay for the whole time, don't worry. You'll get a link to the recording after we're done here. Next slide, please. And then just as a brief overview for those who don't know, Hobo Data Loggers is now part of Lycor Environmental. Together, these companies have over 50 years of experience in environmental monitoring. And after talking with both groups, it just made sense for us to come together like this. Our sole focus on the Hobo side is on accurate and reliable data logging and monitoring. Our facility is located in Bourne, and we've been a world leader in data loggers with a global network of distributors for quite a while now. And with that, I think that wraps up my part. Alex, Justin, feel free to take it away from here.
Awesome. Thanks, Xander. Appreciate it. I'm going to share my screen so you guys can see me just for a couple minutes while I do the quick intro to QGM. I also very excited to be here alongside Justin Mamaris. We were college roommates at UMass Amherst, and that was about 15 years ago now. So time flies, and especially when you're having fun. So we decided to establish QGM Consulting in 2021 out of North Kingstown, Rhode Island. We are 7 employees now, and so still very much a small business, and that allows us to offer, tailored facility solutions for large industrial and commercial clients. And I'll say in the greater New England area, I guess, if that's a thing. So New England and, New York, New Jersey, and now beyond, we're starting to get some traction with some of our larger clients across the US. So facility solutions, very broad, but mainly focusing in energy audits, load studies, mechanical audits of steam, compressed air, chilled water. Over the recent few years here, a lot is being focused on electrification and decarbonization. So that's become a good topic for us. Working with the local utilities for their energy efficiency program development support. And we also specialize in securing state and federal incentives and grants. And then the main reason why we're here is data logging. We do a lot of data logging, and we buy a lot of data loggers. So that's why Hobo, I think Hobo asked us to present for them. And with all these studies, we've seen a shift in the market. More savvy manufacturing customers are starting for process studies. So we're going to get into that specifically today. Process energy metrics or production energy metrics, PEMs. We actually presented this idea at the 2023 AEE World Conference. So that's QGM. And now for a real brief agenda. So how does the industry currently utilize energy and production metrics, and the general link between the generation generation of energy and then the actual process use? We're going to really highlight the production or process energy metrics. We really feel it's the next step to optimize production and understand your process. And then obviously, how do we utilize data loggers and meters to develop these PEMs? And we'll go through a few examples and strategies and results that we've gone through over the past few years. A lot of these topics are closely related to ISO 50001. Justin's an expert in that, and we'll be able to kind of see how ISO 50001 incorporates into the PEMs. So yeah, I'm going to kick it right over to Justin. He's going to dive in, and then I'll be back a little bit later.
Thank you, Alex. Again, my name is Justin Mamaris, the other principal of QGM. So, excited to have everyone here today. And basically, as Alex said, we're going to talk about some of the current processes, let's just say, to handle production facilities with regards to energy and energy metrics. And a lot of this has to do with some of the ISO language and other things that are lean related and things of that nature. But the Plan, Do, Check Act is something that, continually we come across where, people have plans, they try to do stuff, and then we need to check, did we get the results we wanted? Do we need to update, make any more improvements? We act on that, and then it's just continuous improvement from there. Next slide, Alex, please. So when we do planning, we want to have that do, check, act in mind, right? And as we do that, the monitoring is critical. The quicker you can get feedback, the quicker you can analyze exactly what occurred, understand if there's any deficiencies, and if you need to go after any of these, let's call them loose ends, to essentially make your process more effective, more efficient, more profitable. So, to kind of kick into what typically is happening now is sites will identify what we call significant energy users. And again, a very good place to start. We try to figure out what is the most intensive operation, and a lot of that is, systems like boilers, chillers, compressed air, you name it. But what we started finding out is, as we look at that high level building approach, the SCUs, or all these significant energy users, typically can touch many different processes. And we wanted to kind of dive into that more, and we found that we're getting a lot of traction as we go into this type of process. So how do the ISO 50001 play into this? Well, a lot of people are looking at that as a standard, essentially, to understand how to benchmark where they are, to show improvements and gains through basically an accredited organization, as ISO is involved in many other things with quality and that nature. So what they've done is they have what they call energy performance indicators. And a lot of times what we do is we normalize all energy to BTUs or whatever we may want to label them, and essentially start comparing them to production and other metrics. But a lot of times what we've noticed is these are, many different processes or widgets being made under the roof of some of these facilities, and we needed to get into more of a deep dive. So as we went through with the efficiency goals, and understanding where folks wanted to go, and typically it's a 5, 10, 15% reduction that people are looking to go year after year. We started realizing that this energy performance indicator tool, although it's a great way to get started, there was more details that folks wanted to get involved with. And as well as we got involved with those details, more results started kind of coming and realizing themselves. So we wanted to say, how can we do better? And this is where we want to discuss some of the PEM stuff with you. So again, this is just a quick little look at the ENPI process tool. Again, just to go over it, not to beat a dead horse, but the concerns here were high level, not specific enough. So everyone can say, well, I bought a VFD air compressor. Hey, the chiller's got a VFD, the pumps and all of that. We got some controls on it, things of that nature. But what we found is what is actually happening as we make the widget. So this really only addressed generation, doesn't really look at what's being utilized to change the form, fit, or function of any of these products. So as well, it takes time to develop and track these. It's basically on a monthly basis. And what happens is things could happen and you don't catch them for maybe a month or two. So as we go through this, we started realizing with all of that happening, after 2 months, you realize there may be a concern. There's so many variables now built into this tool that it was tough to really pinpoint where to get started to make additional improvements or correct some of the results that we were seeing. So PEMs and ENPIs. So like I said, an energy performance indicator is something developed by ISO to talk about the entire site and how that site's energy relates to just quantity of widgets, could be pounds, could be linear foot of what they're making. You could slice and dice this many ways. But what we learned is that we've needed to get to that next step and look at what happens as we get deep dive into just an actual specific manufacturing line. So the next layer we felt after understanding the site and showing that we have some correlation is to get more specific metrics related to the individual lines. And as we found, as we go around, sites typically do not understand the energy intensity for the products. And that started becoming a question of what product is actually consuming the most as they either go out for new contracts, things of that nature, where they want to understand, well, they know labor and intensity of things, but what do these utilities actually mean to each product they make, and are they charging appropriately enough? So why are these PEMs needed? As we said, tough to track things. So as you see, we got our general kind of layout of site demand where we go, hey, you got some pumps, we got some chillers, you got fans, air compressors. It's easy to start measuring each one of these to go, hey, here's what this consumes with regards to your overall usage of the site. And the pie chart has always been a great way for us to understand what's happening at a site so that we spend our efforts where the energy is most intensive, and as well, not only where it's intensive, but where we can make the most impact. So what ended up occurring was we started figuring out, well, let's get into, and I'll kind of give credit to one of my old professors. He would always say, we got to know the gazintas and gazoutas. So, as an engineer, we like to create a boundary. And what we would do is just draw a control volume around a production line. What is coming in for raw material, what comes out, and at the end of the day, what's going in. So when we started getting into these, we understand that this was valuable information. So we have learned as we get and we dive into understanding what's happening at specific lines and specific equipment and operations and widgets being created, the conversation with the customer really kind of took a different approach where they really were engaged, meaning, they look at a big air compressor and they just go, I don't know, you tell me if it's working well. When you start telling them how much they're using for air, chilled water, that to make each product, they start going, well, I'm not sure if that makes sense, or that's interesting. I didn't realize that was happening. And before you know it, you're planting the seed as to helping people understand where there's intensity, and then is it jiving with what they would expect with regards to the process line that they've, ultimately been running for many different years at this point, right? So we understood this was very valuable information to the sites, and it basically developed the conversation, which to us is the most important part. When customers start opening up, giving us information, that allows us to react and understand if, you know, there's merit to what we're trying to do, or are there too many roadblocks and hurdles? And, you know, can these roadblocks and hurdles be overcome, especially if there's potential incentive money or other benefits that may come to help along the way. So another additional thing that we've found is we can assist with almost research and development. So a lot of engineers design these lines and these processes. And when you kind of give them the raw data that you're collecting on your own data loggers, you know, obviously using a lot of hobo loggers, they start understanding parts of the process they weren't aware of. And once they can kind of get that information into their queue and kick it around with their R&D and with their, you know, as they develop kind of procedures and you know, scopes of work for how they want to develop their widgets, essentially, they start going, didn't realize that that was happening at that point. And again, that conversation just starts snowballing into, you know, that plan of action where we actually do something, get implementation. And then we'll talk about how, you know, with these data loggers, we can get the check, right? We can check exactly what's happening, real time in some cases, and then act upon anything to correct it and make sure that, you know, the changes are a success. You're not waiting months and going, man, what happened? Why didn't it work? And then ultimately we have seen folks just divorce plans for energy efficiency and essentially improvements, going back to the quote unquote the way we've always done things. So the gazintas and gazautas, you know, how do we actually approach, address, and go after this? And, you know, as I spoke about just recently on the other slide, we draw this control volume. Let's draw the boundaries of this process line. And we need to understand, you know, what is being consumed. Is there compressed air? There can be chilled water, right? Many motors, fans, pumps that either are inside the control volume or being fed outside the control volume, depends how you want to kind of draw your dotted line. You know, there can be heat. We got many other sources with direct fired equipment, steam. I mean, you name it, we've seen it. There's almost too much to list, but understanding what's being consumed will help us, one, know the intensity. Then we have to look at what's being produced. And that's been looked at many different ways with regards to either pounds of material, length of material, volume of material. As well, we can start getting into scrap and waste and other things. And I'm sure, as you can realize, if we know how much energy is being consumed and how much is being made, we can put a value to what that scrap, what all of those inefficiencies are worth. And a lot of times that's what we use to talk with customers to say, is this enough of a carrot to help us go to the next step to actually make any changes and improvements?
All right. Thanks, Justin. I'm going to take over for a little bit here on the gazintas and, you know, how we collect the data, right? So it's first, you know, what do we want to data log? What variables do we need to monitor? For how long do we need to monitor it? And what interval? You know, if you get a reading every 1 minute, a lot can change in a process in a minute, right? So that's the reason why we do like hobo loggers. They can go down to 1 second intervals for up to, I think, 3 months or more. So it's very important to understand those three criteria, right? And then, you know, all the different types of monitoring equipment that we use is very broad. So whether it's just electricity, could be compressed airflow, straight power, pressure, temperature is big. So getting delta T's across a heat exchanger, for example. And we can utilize a lot of the hobo loggers and equipment to do this. And I think that's why we've been successful, is we're very good at collecting the data and then presenting the data and letting the data speak for itself, right? Once customers see the data, it typically opens their eyes and says, oh, wow, okay, let's work on that, or let's focus on this, or how can we make that better? So the gazintas is very important. Obviously, that's how we baseline the energy use, or the fuel, steam, all that. So here's kind of, some highlights of some of the data loggers we use from Hobo. Like I said, what to monitor, how long. We like Hobo because it's easy to use, very easy to deploy. They have a nice software for analysis. And most recently, we've really enjoyed working with HoboLink. It's their cloud monitoring system. So you simply need a gateway and a internet source, and then it can all go to the cloud, and you can see it near real time and actually download the data from remotely. So we can do our auditing in almost half the time without going to the site. And this is part of the real time constant monitoring. You can make a change, look at the data, and see what happens. So I don't have to go through most of these, but we use motor on off, pressure sensors, thermocouples, obviously current transformers, 4 to 20 milliamp output cables, and 0 to 5 volt is very useful on some applications, but there's a wide range that we can use. I figured I'd throw in some pictures. On the left here, we did a large load study, so we basically metered everything in the facility to get a good baseline on basically every end use. So in this panel here, we have 3 hobo loggers and maybe 12 CTs, and we actually have a power meter hidden in there too, measuring power. In the middle, that's a compressed air flow meter with a 4 to 20 milliamp cable going to a hobo data logger to measure CFM airflow to the building. And then on the right, we have a couple disconnects measuring amperage and power. This was to a large air compressor. So obviously, safety is key when you're installing these and should be done by a licensed professional. So defining the widget is critical, obviously. So that takes discussions with the facility, and this isn't some of the first items that we go over when we're in the plant, right? We don't say, hey, how much volume of metal do you guys make? Or this is after we've had some history with the customer. They trust us. We've been in there working with them, but they're, like Justin said, they're more open to giving us some of their data, right? So quantity, it could be jars, cases, bottles. Obviously, if you're a bottling plant, you know how many bottles you make, right? Volume of material, length. But defining that widget is critical, and it could be widgets per line, individual widgets. But that is all the first step. Also important is, scrap rates. Those consume energy and rework time, obviously. What other byproducts can come out of that? Is there a waste stream that you can sell for a byproduct? And then other energy losses. Is there just significant waste heat going out the stack? Condensate going to drain where it's not being recovered? But all these questions is needed, and it gets conversations going, and it gets people engaged. And our goal is to, get people excited about optimizing and making their product better. So it's like Justin was saying, customers really were interested when we started monitoring, the compressors and chillers, and they said, well, I wonder what, line one is costing me for energy, because I really need to know for pricing, and I just want to know how much energy is going to that line. So we started looking at line one versus line two versus line three, and then once we get the data, it's, oh, why does line one and line four use twice or three times more energy than line two, right? And maybe line two and three are newer processes and newer equipment. So we're almost detectives, right? And we're trying to find out where the energy is going, why it's being used, and when, and if it could be improved, changed, or optimized. And this general process map, obviously it all starts with the billing review at the high level. We also like to look at utility interval data, which is 15-minute readings from the utility. Many new smart meters have this. From there, we can utilize that ENPI tool for the site metrics, and that's at the high level. We could do all that without visiting the site. And then once we're on site, we then need to start understanding the actual processes, the significant energy users, where we want to monitor, what we want to monitor, how long. Again, then we install the metering and develop those specific production energy metrics. And then the actions, what are we going to do with this data? And then act. Let's implement some changes. And there should be another line there that kind of goes back to the start, where we're continuous improvement. And I'm going to kick it back to Justin for some examples.
Oh, thanks, Alex. So, where have we been able to make some improvements? I'm sure everyone's a little curious. So as we go through, there's a variety of different ways. I'm sure you can imagine no specific process is identical to another. Even if they make the same thing, I've been to plants that exist 15 minutes away from one another, making the same product, and it's different. If they were choosing to make it the same way, one would have overtaken the other, is what I kind of have come to the realization. So you realize that everyone's got some sort of proprietariness to this. And as Alex said, part of this is gaining trust with the customer over years of relationships, of looking at the other systems and, letting them know that the data is accurate, the data is real, the loggers work. How can we use these to help you out? And a lot of times it comes down to an oh boy, oh no moment where, I don't know, something happened. We get a call and we come down. And this is an interesting example here where we started working with a new site, that literally brand new site. We go down there and we realize that they had a big bottleneck, and to the point where they couldn't run. They had built 2 lines, but they could only run 1 line at any given time. And they had some concerns with demand and things of that nature that we went through and made sure they were fine. But we wanted to help them understand what was the difference between running 2 shifts. And what happened was they did have the 2 lines, and they started splitting the product between the 2 lines and only sending a certain amount of mass to each line, where the equipment before and after just couldn't handle total throughput. And it was a big investment for them. And we had to kind of go through to see, well, what's going on? And this was an interesting one where we started going and digging in, and we realized that they have this huge drum that they've got to spin, and they put a lot of their product in there, and think of it as almost like a big tumbler to help kind of polish the media that they were putting through. And again, what we started realizing was it was very intensive, and they were running 2 of these, and there was about 400 or 500 horsepower motor associated with each one. And what we let them know is that a lot of the majority of the energy and demand was just to spin the rotating mass. Their product was actually a fraction of that mass. So we started talking about, well, how can we alleviate the bottlenecks? How can we go about making sure you can get the throughput through the other, equipment, so that you could just run one line instead of two? And I'm sure folks are putting the dots together, or run two at double production, right? And really ramp up, cut hours of operation, whatever it may be. And, we were able to prove out, and this project was actually installed, and they got the equipment before and after that would allow them to make gains where they could put double the throughput through the machine. And by doubling their throughput, they really only increased the mass and the energy by, a fraction, between 10 to 15%. And that became a real big win for them. And because we were able to document it in a great way, it was able to go to the utility, gain some incentives as well to help out with the costs. And as you can imagine, everyone was happy with regards to the results and the funding and the quick ROIs associated. Even though they thought it was a big cost up front, the ROI actually became very quick for them. So kind of just going into here to let everyone know, we had air compressor energy, right? Big process motors, blowers, fans, dryers, you name it. And really what we see is the big intensive portion was the actual running of those process motors. And we can see here we have the existing operation on the left, which is what they were getting done, right? And we have an energy intensity there of almost about 0.1 kWh per pound of product. And when we run additional hours, right, they could double how much they're making. But again, they were at the same energy metric. So as we started looking, we said, well, what's the percent increase expected? And as you can see, I mean, the compressors, the blowers, the fans, they needed to all run significantly more, but they weren't really the main driver of this process. What was the main process motors. And that's where actually it was only a 5% increase overall to actually achieve what they needed to. And as you can see, we were able to improve their metric by about 30% reduction. So therefore, they were able to make all of this product, not have to run 2 shifts, hire new staff, that and the other thing, which isn't even kind of factored into this. And again, make huge gains as their industry was growing. Some of the other things we've looked at is, and actually it's interesting, we went through this and we got a few customers excited to potentially make changes. And I will admit the insurance companies came and kind of put a stop to it due to regards with their concerns with electric heaters. But we had a lot of customers, they use steam to heat water tanks. And this was basically specific to the plating industry. And as we kind of went in, we realized we're running lots of boilers. We've got a lot of lines that need to be heated. Whether they need to be heated all the time is a different thing. And I'm sure, as you can imagine, I'm sure you've seen on-demand hot water heaters, things of that nature. They essentially are better because they only use energy when they need to. And when you get these big central systems, we're sending steam and everything everywhere, whether you need to or not. And that's kind of standard in industry, right? So we looked at the difference between steam versus electric plating. And as you can see on the left, we had just about 50 tanks. And when we look, the tanks are in operation a majority of the time for their single shift. And we were able to put, what is the BTU per tank per hour? And that was essentially what's the boilers using that are feeding these lines, account of the lines, and you name it. They did have some electrically heated tanks as well. And so we just kind of ran an understanding. This one was interesting because there is slightly a cost increase to operating with the electric heating. But what we learned is the BTUs really, drop down, right? We almost cut them by almost 80%, 75 to 80%. Obviously, electric cost per BTU can be 3-4x that of natural gas in some cases, and that's why even with the efficiency that we saw, you're seeing similar costs to operate the lines. But when we look at the MMBTU savings, and especially the metric tons of CO2 that could have been available, it was very much a driver and would be a driver for a number of customers. Again, I'll be transparent and admit what we found is that the insurance companies were not too keen on having these electric heaters, as I guess a number of plants have burnt down because of, tanks basically being overheated, the water kind of, draining out, and now you just get this element that's running and starts melting things and creates a hazard. Even with safeties and automatic fillers and floats and all of that, we found viable solutions, but at the end of the day, no one's willing to really go against the insurance company. So I don't expect, this to never come to light. I assume someone will find a better way to get that done. But for now, the insurance companies are the ones kind of stopping any of those projects moving forward, interesting enough. And then kind of just a third example, and this is a really big gain that we helped one of our customers make. And really what we found is, and we've seen this at a number of different plants, it's just this plant was actually willing to act and try to make the changes. Again, we see these big horsepower boilers, 1,000+ horsepower, feeding tens of thousands of feet of steam piping that in some cases literally end up nowhere. As you can imagine, processes back in the day, they would just tap in and keep using more and more steam, and you've created this vast network of a spider web of steam distribution. And it doesn't matter how often you insulate or you get in there and you kind of take advantage of it, it's basically a waste. And what we were able to do is do some kind of, savvy kind of data logging with the hobo loggers and things on some, condensate stations, and strategically kind of repiping some things to really make sure we understood what we were going after. And lo and behold, we actually worked to say, all right, well, what is the boiler using? What does the process use? And what we found is that there was 60% losses essentially from the whole entire system. And with the data loggers, we were able to go through to talk about, well, where is the natural gas going? There was some heating, there was some process. And as you can see, the process was only 10% of the total usage. The rest of the energy was going to some cooling, distribution, things like that. And you may say steam for cooling. Well, yeah, they had steam, so they just used absorbers and things of that nature, which made it even worse. And we're running these big boilers for really no reason. And I'm sure you can realize we ended up going through, and instead of running thousands of horsepower of boiler, I think we got 530 horsepower systems essentially sitting around the plant feeding the specific lines. And all the office heating, production heating just went to direct fired style units that were just fed a natural gas line. And again, that allowed us to only use things when we needed to use the energy. And they ended up saving 50% of their actual total gas use, which was a lot, I'm sure you can imagine, with a 1,000 horsepower system. So other examples, like we said, is, the review of these central systems. Do they make sense? A lot of times we're finding that there's better ways to maybe, allocate energy, end uses so that we can shut them off when needed. Back in the day, I think, we had more booming, 2-3 shift operations. And at the end of the day, this isn't meant to shut things off for, 4-6 hours at a time, but, on the weekends. And, some of these metrics actually force our customers to actually understand how they're going to process workflow. Are they going to batch certain products and operate them, say, on Mondays and Tuesdays, and kind of change the business? And it's interesting enough to see people do this once they have been shown the metrics, the data, the potential savings. As well, review of the legacy equipment, as Alex said. Why is line 1 consuming more than line 4? They make the same thing. Well, that one has a new, a new piece of equipment versus the other, and lo and behold, you're finding out where that gain is being made as you develop these metrics. And again, financial planning and operational costs. We've had customers reach out to go, I've got contracts coming out. Am I charging enough for the product I make? I'm not sure if this is more intensive than that product I make. And I've just been assuming it all goes. And, now that they have to buy new equipment to help, support these processes and the additional costs associated with all of those, upgrades, it really starts to beg the question, is there enough money being compensated through the product to help with any additional things that need to be added to the process site, things like that?
All right. So next steps, future process optimization. Like to say here, you can call QGM or start implementing some of this on your own. Obviously, the plan, do, check, act, and repeat. Expand monitoring of specific production lines, refine the metrics, and then obviously enhance the services with energy efficiency, not just process efficiency. Real-time metering is going to be, I think, big. Once sites understand how valuable that energy and production data is, they want to see it all the time and make sure they're staying on track rather than month to month or week to week. They can almost do hour to hour. Like I was saying, utilities specifically in New England region are have great programs, and there's many more across the United States, and this data logging allows you to identify many opportunities for energy efficiency and savings. We love it. It's helping the USA manufacturers. It's adding competitiveness, jobs, and reducing waste, and we're saving the planet, right? So that's what we're all here for, right? So some conclusion, key takeaways. So for larger sites, more intricate processes, we may require an additional review in lieu of the strategic significant energy users in the ENPI process, and that's where PEMS can come in. Again, this is new, and we're just starting to develop this with customers, but we're excited to be working on this right now. It really gets the customers engaged and educates them on how much the process is using for energy, right? And it's important. And so by helping the sites better understand the energy intensity, they become more aware, engaged, and it's a win-win overall. And production and manufacturing really is, they're there to make a product, right? So whenever you can optimize how much product is getting out the door for cheaper, typically customers are on board. And this is really the start of it, because PEMS really help evaluate what that is. So please add some questions into the chat. We got a few in there now. David wants to know if you are a New Yorker. Justin does have an accent. He's from New Bedford. I am from New Hampshire. I do have a cold, so maybe that's part of it. And then John had a question about the flow. Is flow ultrasonic? So for compressed airflow, it could be ultrasonic or hot tap thermocouple type insertion meter. So it could be both.
Yeah, I see
David,
that. we're saying more lower utilizations they've seen for steam, and that's definitely the common thread we've been noticing. Is
Yeah, we
lack.
found that steam plants are not very efficient at all. From natural gas in to steam going to the process, it's not very efficient. And yeah, these slides will be shared and emailed out. I think they'll also be located on the Hobo or Lycor website.
Yeah, I can jump in here and answer that, Mike. So all the presentations will be available for watch on demand after we're done here. It'll be up on our website, and you'll be emailed a link to it after we're done too, in case you want to rewatch it.
Yeah, and our contact info is here. Please reach out. We do have a couple more questions. Case study 3. There was a question. Which Hobo data logger types models were deployed? So Justin, that was the the big steam plant, 1,000 horsepower of natural gas boilers. I know there was a lot of loggers deployed. If you want to go through a few of those.
Yeah, essentially it was to be honest with you, it's not even the data loggers at the end of the day. They prove out the concept, which is great, but it was actually a lot of legwork, a lot of one-line diagram tracing, understanding where the networks went, understanding where we had some steam pipes, and I've seen this worse in others facilities, quarter-mile long steam pipes that literally don't go anywhere, right? 10-inch in size and things of that nature. And it's really just as you're walking around, we had a savvy customer who would go turn off steam valves that were going to these dead networks, and he would say, I noticed my 1,000 horsepower boiler react to this valve. And so as you kind of went and traced it out further and further, we did get down to the specific equipment level, and using various of those Hobo data loggers, from just standard on-offs to actually capturing loads on pumps and understanding where their curves were to returning condensate and things of that nature, to really get an understanding, as well as working with the site engineers themselves. They wanted data loggers placed in certain locations to prove out their assumptions and make sure they were comfortable with any changes we were going to propose and or make. And it was just a kind of concerted effort. But the data at the end of the day, once we did all that legwork, basically came from just the typical standard MX and on-off loggers to say, here's what we're seeing, here's how they relate to kind of the process. And once you kind of give them that, everyone basically jumps on. I'm sure if you've gone into some of these, there's always someone that's the naysayer, right? We can't do this, we can't do that, we've tried this. And having that data and giving others in the room confidence to be like, well, we didn't try it this way, we didn't do that, started overshadowing kind of the we can't and I don't want to try this. And again, it was just all the due diligence. That project took about 2 years to develop, just to give everyone an understanding. It took about another 2 years to get it all installed, and the customer has been living for about 1.5 years, 2 years with the savings. And again, I'm sure, as you can imagine, they got us started in a few different other areas now to do the same in the electric side if there's potential opportunities. So good stuff.
Another question. Is it possible to use Hobo device to measure light levels in the same way a light meter does? Yeah, 100%. Hobo has light loggers, and we would also recommend they have the motion sensors built in. So it tells you the light level and if there is motion in the space.
No, actually, those are 2 different loggers we have to use. One is an occupancy light logger, so it'll determine occupancy and light. and then
Yep.
we'll deploy, I believe it's the MX 1104 or the single channel temperature. That one has a light intensity meter
Light
on it
intensity.
that is actually really well to be used to understand if with that occupancy, if lights are actually dimming when they're supposed to, as well as it can capture solar gain coming in. I shouldn't say solar gain, but light coming in for daylight harvesting off of the windows too. You'll get this, you kind of like nice, you know, almost like a horseshoe effect of, you know, as the sun comes up to going down as that light increases. And we've used that to prove to people that daylight harvesting might be, you know, worthwhile in some places. But you
Yeah,
need both.
I'd say it's important to make sure you locate the loggers properly too. Because they do have the motion sensor. They're rated between, I think, 5, 10, 15 meters of distance. But yeah, all those are located on the Hobo website. Last call for questions. I think I hit all of them. If I didn't, just type it in again. But yeah, please reach out with other questions. Happy to discuss what we've been working on and see how we can help anyone in the room.
Yeah, Alex, Justin, thank you so much for taking the time to present today. Again, if you do have any last minute questions, feel free to type them out now. Otherwise, this presentation will be available to rewatch. And then I guess, Alex and Justin, if you just want to go to the very left side with your contact information, in case anyone missed it too, we can
There we go.
wait there for another minute for anyone who wants to grab it. And then otherwise, I think we can call it here. Thanks so much, everyone.
Thank you, Xander.
Thank you.